If you go ahead and turn worksheet 713 onto the back side, I want to attempt one of these questions with you where they give you the original ratio and they give you just a little bit more information, okay? So if I look at question 13, the first thing I recognize is that they gave me a secant ratio. So they gave me that the secant of theta is a -2/1. And when I look at that, my first thought is that I recognize that secant is negative. But the problem with that is, according to what we did before, we didn't use the word secant in our chart. We used the words sine, cosine, and tangent. So if we look at the chart that we created earlier, ASTC, instead of looking for secant in my chart, I'm going to just search for the word cosine because that will have the same positive or negative value. So I need to find a quadrant where cosine is negative. So I'm going to write that up above the question. I need to find where cosine is negative, and according to the rest of the question, sine has to be greater than 0, which means sine has to be positive. So looking at the two possibilities where sine is positive, sine is only positive in quadrant 1 and quadrant 2. And in quadrant 1, everything is positive. So this doesn't really help us because our original question said that cosine had to be negative. So in quadrant 2, sine is positive, but everything else is negative. So that tells me that when I go to build this triangle, I want to sketch the triangle so that it's formed in quadrant 2. This is where we're looking for. All right, so now when we go to sketch our triangle, if you remember from yesterday, we want it to look like kind of like a fourth of a bow tie, and the right angle will always be touching the x-axis, and theta always goes nearest the origin. So when we go to label my triangle, I can use the fraction that they gave us in the original question. They told us that the secant of theta is -2/1. Well, if you remember, cosine of theta was adjacent over hypotenuse. So that would mean that secant would just be the reciprocal. So that means it's hypotenuse over adjacent. So when I go to label my triangle, if I start at theta, that means the hypotenuse has to be 2, and the adjacent side has to be -1. The reason I didn't put the negative with the hypotenuse is because we talked about the fact that the hypotenuse always has to be a negative, or it has to be a positive value. Another way to think about it is if I were to get to this point at the tip of the triangle, I would have to backtrack one space to the left, which means to move this direction to the left would be a negative movement. That's why I want to use a -1 on that side of the triangle. So from here, we're just going to use Pythagorean theorem. So we're going to do -1 squared plus x squared equals 2 squared. So we'll get 1 plus x squared equals 4. If we subtract the 1, x squared would equal 3. And if we square root that, x is going to be equal to the square root of 3. So that means up here, I can label the square root of 3. Okay, if we were plotting this as an ordered pair, again, going back to the point at the top of the triangle, this would mean I would have to move backwards 1 unit and up square root of 3 units. So this number is going to be a positive value because the movement goes up. All right, so before we actually start solving the problem, let's just look at writing in the ratios as far as positive or negative, just to make sure that we do this correctly. So we have sine, cosine, tangent, cotangent, secant, and cosecant. So just to keep things straight, according to what I circled in green off here on the right, the only thing that should be positive should be my sine ratio and my cosecant ratio. So I'm going to put a positive next to that, and I'm going to put a negative next to the other words, just so when I get done, I can double check that I labeled things correctly.